Hello, fifth graders, it's Mrs. Belatash. Could you please get out your science notebook? And I want to make sure that you glue in this page, the night sky log, and this page, phases of the moon. And since we're in our science notebook, we need to go back to the beginning, to our first page, the table of contents. And I put number 3, moon phases, and mine is on page 6. And then number 4, Earth, Moon, and Sun, and it's page 8. So that's what I did. Your page numbers might be different, but we're gonna add these things to the table of contents. Okay, so I'm gonna go back to the pages that we just glued in. So you finished that video about the phases of the moon, and that was a delicious project using Oreo cookies. I would like you to do a little observing, right? Observing is like the fundamental part of science. I want you to go and let's take a look at this page, the night sky log. Bring this sheet back to school on Friday morning. So we're not going back to school. I wish we were. But on Monday, I want you to go out and look at the moon and put the date, the time that you went, and any observations that you noticed, okay? On Tuesday, Wednesday, and Thursday. So I want you to really pay attention to the moon. So boys and girls, it doesn't have to be Monday, Tuesday, Wednesday, Thursday. Whichever day you guys decide to start this project, just cross out Monday and put Thursday, Friday, Saturday, Sunday. I want you to watch the moon for 4 or 5 days in a row so that you can really start to see how it's changing its shape. You might want to go to the internet and find out what time the moon will be visible so that you, on the days that you watch it, so that you can see. The next page shows the phases of the moon that we see from Earth, right? The moon is actually always half dark, half light, but we only see different amounts of light because the moon is orbiting the Earth. It takes 28 days for the moon to orbit the Earth. So go ahead and draw the phases of the moon and list their names. The next thing I want us to look at is really the distance and the size relationship between the sun, the Earth, and the moon. So I have this little model, and while the model is great, it really does not represent the space that's in between each planet accurately. So what I would like to do is for us to be able to make a model that represents the true size and distance between the sun, the Earth, and the moon. So in your packet, you have this page. It says modeling Earth, Moon, and Sun. Please make sure this is in your packet, glued into your note. So on the packet, it says, here are some data about the Earth, the Moon, and the Sun. And it says the moon is 3,476 kilometers in diameter. The Earth is 12,742 kilometers in diameter, and the sun is 1,400,000 kilometers in diameter. So you guys know what diameter is, right? So if you go around, that's the circumference, right? And if you go from one side of the circle, if you cut this in half, just across, that is the diameter. And if you go from the center to the edge, it's the radius. Geometry, it's awesome. So I have the Earth, and this Earth is 12 centimeters in diameter, which is just about the size in kilometers that the Earth is, right? It's a little bit smaller. The model is slightly smaller. Then the moon, this moon is 3 centimeters in diameter, and the diameter of the real moon is 3,476 kilometers in diameter. So I have 2 objects that are almost the correct size of the Earth and the moon in relation to each other. Now I want to find out what is the distance that they should be away from each other. In order to do this, we're going to have to do a little bit of math. Yay, math! So we know it says that the moon is 30 Earth diameters away from the Earth. So an Earth diameter is 12,742 kilometers. But we're going to use this model. What is the diameter of this Earth model? 12 centimeters. And the distance the moon is from the Earth is 30 Earth diameters. Can you do a little math and figure out how far away the moon should be from the Earth? So I'm just kind of just estimating right in my head, right? So 12 centimeters is about 10, right? 10 centimeters. And I know that the moon is 30 Earth diameters away. So 30 times 10 is 300 centimeters. So that's just an estimate, right? Of course, I wanted to be more specific or wanted to be more precise. I would do 12 times 30 equals 360 centimeters. So now I'm going to show you how far away that is in reality. So I made a little model to show the true distance between the Earth and the moon in terms of their relative sizes and distances. So here is a 12 centimeter sized Earth, and the moon would be 360 centimeters away. This is how far away the moon truly is if the Earth is 12 centimeters and the moon is 3 centimeters. Quite a ways. So if this is how far the moon is from the Earth, if this is the Earth's size, how big would the sun be? Well, the sun would be about 45 feet in diameter. So it would be very big. It would be bigger than my classroom, than the science lab. And the sun would be a mile away from this Earth globe in the science lab. And that would be about right in terms of space in between. Okay, before we go out and do the planet walk, I want you to look at this like a standard model of the solar system, right? Most of the time when we see a model of the solar system, we see this great big ball of the sun, and we see some planets. We see Mercury, Venus, Earth, and Mars. We see Jupiter, Saturn, Uranus, and Neptune. And they all look pretty close together, right? And this is kind of how we imagine the planets really are like. So in a minute, we're gonna go outside, and I'm gonna give you an idea of how much space there is in space. So imagine, if this model is accurate in terms of size of the planets to each other. So if the sun is this size, then this is the size of Mercury. If this is the size of Earth, this is the size of Jupiter. But it is not accurate in terms of the distance. So now we're gonna go outside, and I'm gonna show you a video that shows you if the sun was very small. I've got this little tiny ball outside that's gonna be the sun. I will show you the relative distances between the planets. It's pretty cool. All right. Okay, so we are going to do something called a planet walk. We're going to start at the very beginning with the sun, and we're going to look at the first 4 planets: Mercury, Venus, Earth, and Mars. Here's the sun. So if the sun is that size, that beautiful little orange ball, if that's the size of the sun, here's Mercury. And Mercury is really small. I actually had to make the dot a little darker so you could see it. I couldn't even see the dot for Mercury. And if the sun is that size, Mercury is 1 foot from the sun, okay? All right, next comes Venus. Here's Venus. And Venus is about 2 feet away from the sun. Here's Earth. And Earth is about 3 feet away from the sun. Now, Mars is a little bit farther. Here's Mars. Mars is a little smaller, and it's about 5 feet away from the sun. So you can see that's our inner solar system, okay? And they're pretty close to the sun comparatively. Now, the next part of our solar system is Jupiter. Let's go find it. We'll keep walking and walking and walking. Oh, here's Jupiter. There it is. And Jupiter is pretty big compared to the other sizes of the planets. And let's see how far away it is from the sun. Pretty good distance before you get between Mars and Jupiter. Okay, after Jupiter comes Saturn. So we're gonna walk and walk. And here's Saturn. There's Saturn. And let's see how far it is away from the sun. There's Jupiter. There's Mars, Earth, Venus, Mercury, and the sun. Okay, after Saturn is Uranus. Walking, 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 walking. Here it is, Uranus. It's smaller than Saturn and Jupiter. Let's take a look. How far is it from the sun? Wow, it's quite a ways. All right, after Uranus comes Neptune. We're walking, we're walking, we're walking, and walking, and walking, and we've come upon Neptune. Wow, Neptune is so far. Look how much space there is in our solar system. Neptune, Uranus, Saturn, Jupiter, and the inner planets. There's a lot of space in space.